Welcome to clickmyproject.com.
Our product title is a configurable parallel hardware architecture for efficient integral histogram image computing. Now we are going to discuss about our product abstract. So integral histogram image play on the important role in the accelerations of the feature computing in the vision applications. The first used some area table of designs and aims to achieve the computing for features algorithms is constant, and then computing complexities. The integral histogram values equal summation of the histograms the top left region's portions. This position according to the figure image, the current integral histogram values dependent on the previous integral histogram values. So the operation integral histograms needs to have access the original image memory frequently, which cache the large number of memory access in the practical implementations. The memory capacity for the file integral histogram image is proportional to the number of histograms. So we are getting some input image we have compressed and decompressed. So we are get the histogram value one input images histogram and compressed image histogram and then decompressed image histograms. Though we are checking the loss file, we analyze that input image histogram value and decompressed image histogram value. We have compared and then get the responding low corner points. So more than equivalent to the summation of the integral histograms of the integral histogram values. The summation of the histogram in the regions of the important properties to acquit the useful of the first and last and regions of the computings, which is the core part of the many features algorithms used the integral histogram images. So and then we have most important of the objective for the compressed. So we get the compressed image for histogram values and then decompressed images for histogram values. So many features algorithms can be used. The methods exploit the previous computing histogram and update the new histograms by adding the columns histograms and removes the old ones. Same times we have implemented the hardware support summarize the histogram values, specify the reasons. Now we are going to discuss about our product flow diagrams. So we are getting the input some original image, and then we are whatever image we give the get the histogram input image. So and then you have going to the filtering process. LPS low pass filters and based on the vision application can be accelerated. The advanced technology size of the image and the challenge to the vision applications. The computing complexity of integral histograms is heading high, and we mentioned about the integral histogram computing is characteristics of the high data dependency and frequency memory access. And then update the point of the previous work came to the performance of the using multi-core platform and the graphical processing unit implementation of multi-core and programize the power efficiency. This came the some design specific hardware design. The point we get the binaries and histogram computing and core platforms and power efficiencies. And then we have using the discrete continuous transform wavelet form, using that summarize the histogram specific regions in constant times, and it's more useful such kind of applications. So quickly the efficiently compute the integral histogram image needed to add and the implementation of the integral histogram computing and the multi-core platform. The in some parallel hardware architectures is summarize the histo values, and then we compress the image and then get apply the encoding process. The architecture we are going to apply the mux and some addition process. We are going to the encoding process and then apply the inverse DCT formulations and then decode the compressed image, and then we get the value of the compressed image also histogram. and then whatever decompress resize of the image and the reconstruction of the image. The reconstruction of the image is the decompress of the image and then get the compressed image for the decompression image. Now we are going to discuss about our product running procedure. So this is our main MATLAB coding for how to get the input image. We are getting how to get the image from MATLAB. So we are using only embedded coding. So this is process. I can explain that. So how to get the input image, how to read and how to get the show the images, and then this is the input for the histogram process. So I have using the IM and the A variables. So this is the input image for that histogram image for the image, and then you have compressed and how to compress and decompress the process is gone, and then automatically open the silence code for this. How to give the one option for the enter the any key display the output for the decompress the process after the running the simulating tool. So now I'm going to running this process MATLAB coding. It will be same get the input. So get one path from this process automatically open that and will search and give the input. So I give the search input sample image for I can give the any pictures. So that's it, I give the input images and then open, automatically open the histogram image open, and then this is the many output of this. So gray to this is the histogram image for input images, and then I get the input images show that, and then noise selected input signals, and then denoise the signals is the same. Meanwhile the same time is silence tool is automatically open, and then its classes will be run. After that we will compress that decompress this process and we will show that the silence software is automatically open. I can running this process. So simulation, click the simulation and then double click the simulate behavior model. It's running the console the process simulate behavior model complete successfully, and then ISLM tool is automatically open and we get the view the process clock symbols. Yeah, the ICM's process is automatically open and this process is completed. This why we are using the silence. We are getting the input from MATLAB and then using the silence software. The intermediate functions is a transformer that and get the output is will be the in silence. After this process running that, so everybody we give the default and reset enable pins we are given the in default encodings. At the same time we are going to this process is success. So how do we intermediate to both tools Simulink that MATLAB and silence, and this process is completed. After we are going to the, so this is a main command window. Enter any key to display output. So you can enter any key, the compress and decompress image it will be automatically sorts. This process is successfully we got the output for the image, the previous the image for that. This output for the how to implement that decompress the process.